A very good afternoon to one and all present here. Again, a very warm welcome to the Faculty Development Program organized by our HO, I Nurture Education Solutions. Today, as we know, we are on day 3 of our FDP, and we have another few more days to go because we have a long, extensive 15-day program. So as a just short recap of what we had for the first 2 days, on the first day, we had an extensive workshop with our CLO, Dr. Shraddha Kanwar, on meta competencies, where the focus mainly was on learnability. And she gave us some in-depth insights on the learning to reflect, learning to learn, learning to regulate, and learning to collaborate. We indeed enjoyed that session very much. And again, yesterday's session, which was from our very own team member, we can call him a team member because he leads our team at Jain Deemed to be University, Dr. Nachappa sir, who is the head of the School of CS and IT at Jain Deemed to be University. He gave us an in-depth knowledge on the higher education system and most importantly about the outcome-based education. And I'm sure after yesterday's workshop on the outcome-based education, I'm sure all my faculties who have to give a deadline, they have a deadline to submit your TLEPs and your session plans by tomorrow. I hope the workshop of yesterday has been of help and you guys are all working on it. Well, on this note, let us go today for today's workshop, which is going to be on the scope of AR and VR technology. Now, we all know that AR and VR is something which is in time. It's with this is something an in thing which is there, and we all need to at some point of time adapt to this technology sooner or later. And so we have with us Mr. Abilash Ashok, who is an AR VR cloud architect, a solution architect, technology evangelist, and entrepreneur with 12 plus years of experience in Microsoft technology stack, who's currently helping engineering and industrial customers in modernizing business using AR, VR, MR, and Azure cloud technologies for industrial 4.0 transformations. Mr. Abilash has an in-depth experience in design and develops complex software platforms with proven background in shipping enterprise applications in multiple platforms of desktop, web, mobile, and tablets, and in the extended reality space. Mr. Abilash will now help us understand the scope of AR and VR. We welcome you, sir. Thank you very much for accepting our invitation and being here, giving us your time and support for this faculty development program. Welcome you, sir. On to you.
Yeah. Hey, thanks, Rini. Good afternoon, everyone. Thank you for the invite and the warm welcome. So I'll be talking about AR, VR, and MR technologies on a broader scale. The entire session will be discussed mostly on the demos and concept rather than the text content that we typically see in a presentation. So I'm directly getting started into the topic. So just a minute. Please let me know when my screen is visible.
Yes, sir. Your screen is visible, sir.
Okay, so good afternoon, everyone. One more time. So today we'll take a peek at the AR, VR, and MR technologies. What are those technologies? How that is being differentiated? What are its use cases? How this technology can leverage the entire experience factor throughout in different industries. So I work at Signed as a solution architect for creating AR VR experience for engineering customers. So at Signed, it's mainly an industrial and engineering customer. So we deal with machineries and helping customers to create virtual reality trainings, AR maintenance applications, on how to make them productive on their day-to-day job basis. So today this entire talk will be at the very simplified manner so that you can grab the concept what an AR, VR, MR technologies and where they are mostly applied. So, so let me start with AR. So I assume that most of you might be familiar with the Pokemon Go, which is the augmented reality enabled game that triggered the entire interest and the experience factor for augmented reality. So in a simplified manner, augmented reality is a technology where you bring your digital content into our real world. For example, if you look at the screen that I've shared, you can see a digital cartoon character right in front of your real world, which is seen through a camera feed of your mobile or a tablet device. So in a very simple way, augmented reality is a experience where you bring your digital content right into your real world, and that is with the help of computer vision and with your GPS data and other sensory inputs like sound, video, and graphics. Now, before we talk further about the augmented reality, I will take you through a 2-minute video demo of the AR. So that gives a glimpse of what an AR experience looks like. Yeah. Okay, so that video is a short clip on how does an augmented reality experience looks like. So if you have noticed in, let me just skip through a few areas. So here the user is using a tablet device for an AR experience. He's launching an application and placing it in front of a magazine in this case. So we call it as a marker in the augmented reality experience. So when you place that augmented reality enabled application in front of a particular content, whether it can be a magazine or let's say right in front of your car or any other object in your environment, the AR experience understands it and brings a 3D model right into your real world. So in this particular example, you can see that you can see a conveyor belt in a factory that is being superimposed on top of a magazine. And you can see the animated view of it and different arms and see how this is working. So this is a very high level experience of what does an augmented reality application looks like. And so as on today, the one of the biggest adoption that we have seen so far is almost all the mobile phones that we carry today comes with the AR enable, possibly from the mid-sized and above. So most of the devices are compatible for doing an AR experience. And so let me, yeah. And the different other use cases that we could think about is, let's say you want to construct a home. Typically, we do that in 2D paper. We take the drawings to our home and we try to explain, or your architect try to explain how does your home looks like. But we always have a bigger challenge in understanding how does our final construction looks like. So in those specific scenarios, we can even use paper, the architect drawing as a marker, and we can use an AR enabled device like an iPad or an Android tablet to visualize the entire 3D content on top of that particular paper. And so that gives you more understanding or conveys more message to you, rather than we had a difficult time understanding the 2D concept. So another example could be like, let's say we were in schools and there are different complex systems that we always find it difficult to understand, like the chemistry, the chemical bonding between different elements, and say the DNA helix of a human body. So we always look at the 2D picture and try to figure it out. So those things can be translated right into an AR, so that the students can hold a mobile or a tablet device right on top of the textbook, and that will bring up the entire 3D experience into the application, and user can see how does the entire structure in a 3D model, and they can go ahead and rightly interact with that particular 3D model and get a deeper understanding of it. Now, it's not something limited to the purpose and the markers. So if you look at, if you remember the Pokemon Go game, I believe at least a good percentage of people might have played that. We walk into the real neighborhood onto your nearest tourist spot or any other sport, and we started playing games there. So apart from identifying a marker in a paper, it also understands your we can also use a GPS location or a geo coordinate to bring up an AR experience, specifically in the case of a gaming. And another aspect of AR is, let's say you hold your camera right. I remember there is an application long time back called City Lens. If once you install it and you launch the application and point your mobile device across your on the place you are standing, it will show different restaurants along with the ratings and different distance to it. So these are some of the use cases that we typically see in an AR. So what is the common factor for all the AR element is it brings your digital content. It brings a digital content. When I say digital content, it can be a 3D model or any textual data right into our real world, which is seen through a mobile or a tablet device or any AR enabled device. Now, I will also show you one typical use case where how does it helps a particular technician to get a job done. Let's say we have a complex machinery, for example, a motor or some other equipment, and how do you want to solve a particular problem? So usually we call the technician, or we call to the service center and book a service ticket and saying that, hey, I have a problem with this, can you help me figure it out? Then we wait for 2 to 3 days for the technician to come to home and start fixing it. So augmented reality is one area where you can do activities with a proper guidance. The 3D model that we bring in animate to respective steps to perform an activity. So I'll play back a video on that, so you'll get a more idea on how best we can use this digital content rather than just simply showing it, how to animate it and guide a particular person to complete a task. Yeah, to give a bit of background of this, this particular video helps you on understanding and doing what kind of maintenance activities that you can do on a motor using augmented reality. Okay, so in this particular step, if you have noticed, the person is using a digital device. It's a tablet, and below there is a printout that acts as a marker. And when he holds the tablet in front of the particular paper, the AR application detects it and immediately shows a 3D model of the entire 2D content.
Sir, just to interrupt you once,
Yeah.
does the video contain any sound or anything which you would want us to hear, because we are not being able to hear the sound?
Okay. Yeah, the video has a sound.
No, if that is not important for us to hear, then it's fine. Otherwise, no. we are not able to hear the sound.
Okay. Yeah, I enabled the share sound. Okay.
All right.
Now it should be fine. Just have.
Yes, sir.
Okay.
Thank you, sir.
Yeah. Thanks for that. Okay, so I will pause a little here and will explain the difference that you have seen here. So in this particular video, what we have done is, let me go back. We first detected the asset, which is a motor in our case. And you can see this particular portion is overlaid with the same shape of the motor. So that is a 3D model superimposing we have done. And this details, what you have seen is pull the details from the system where you keep all those maintenance information. So now we are starting a job for cleaning this particular motor. So we are guiding the user with a step-by-step instruction on how to perform that activity, along with a number of steps to be done. So in the first step, this particular casing is highlighted. And you can see the animations of the screwdrivers coming in the direction in which they are rotating, and the rest of the screws. It is also guiding you to remove what all are the different components to be removed for as part of this cleaning activity. And it also shows a 3D animation of use a brush to clean the fan. So in this particular, we didn't remove the actual piece because this is a working one. This is what I meant. When you have this digital content in your real world, you can do the real simulation of what exact action needs to be performed. So here, this particular unit is been detected, and it is showing how to, you need to select a wrench from the toolkit to unscrew the oil port. Okay, so I'm going ahead and posting the video in the interest of time. Just to come back to this particular use case, you might have noticed that once we does an augmented reality kind of detection, we are superimposing the model out there and helping the activity to be performed with proper guidance. Now, let's say if we are translating that into the education sector where you are mostly interested in, imagine we are in an electronics lab where you want the students to do breadboard kind of experiments, like you take an LED and plug into the breadboard and connect a battery source and connect the power source to it and check the connection, check the validity. Typically in a school or a college kind of environment, the class will be like a 30 minutes to 45 minutes maximum, and the lab can be say 1 hour or 2 hour to the maximum. So that it's not something the students is not familiar to grab the entire concept until they go back and try that again. And assume that we have an experience similar to this that actually performs the guidance of the activity on how to do it in step by step, and help them point showing on how to connect the LED and how to connect the power source into which the points in your breadboard, along with the proper guidance in a 3D animated mode. So this is some areas there we could bring in more value to the education sector. So when I say education sector, it's not limited to just AR. VR and MR will also come into this, that we'll be taking in rest of the slides. So now I am going to VR. Okay, so in now you have seen AR where we bring the digital content into our world using a digital device like a tablet or a phone. Now coming to virtual reality, the experience is slightly different here. We are wearing a headset. So if you have noticed in this particular image, a lady has worn a headset uh, to cover her eyes, and she's holding two sticks. So we call this as controllers in virtual reality. So how this works in total is in augmented reality, you're bringing content to our world. In virtual reality, we are completely taken to a different world, like a entirely simulated 3D world. And just because we are wearing a headset, we are completely blacked out from our real world environment. And when I say blacked out, this means once you wear the headset, you won't be able to see the next person who is sitting by you, and you can't even do an activity with your hand because you are not seeing the world that you're actually seeing. So to interact with those kind of, I mean, whatever objects that coming into that digital world, we are using two controllers which we'll hold typically in our hand and to perform an activity. So in virtual reality, the biggest difference is the user is getting into a full-blown simulated 3D environment, and he need to wear a headset. He also needs to hold controllers to interact with the environment, the 3D environment that we have created. So I'll go ahead and play back a video. Okay, so this particular video is from a VR vendor called HTC Vive. HTC. I'll just post back at critical points and we'll explain it. So if you have noticed here, the user is wearing a headset and holding a controllers with her hand. And what you're seeing behind her is the 3D environment that she is able to see using this particular headset. However, this video is captured using a 3D green room. That's the reason why typically the background, the 3D environment is merged with her background. So just to wrap up, summarize on this, in VR, we have a headset and controllers in hand to interact with it. So similar the case we'll have a simulated environment, and we'll be holding a controllers here. And and you might have noticed that there is a wire running from the headset. So what it does is the 3D environment that is being rendered in the device based on the complexity. Let's say you want a realistic 3D environment, and in that case, the device will not be capable of rendering that high-end 3D graphics. So we'll have to have a virtual reality laptop that will render the entire 3D content, and will be sending back the rendered content to the headset. So for that purpose, we'll have a wire running from the headset to the laptop. But this varies with different devices. So yeah, so this is how the VR experience looks like. You have a controller, you have a headset, you have a controller, and you'll be interacting with the different buttons available within the VR headset. Now, let's talk about the use cases that we typically address here. Imagine, let's say we are talking about an engineering college, and we have a subject of aircraft. Let's say there is an aeronautical engineering subject is there. It may not be always possible for the management to bring in an aircraft engine for training the entire students there, because that involves a lot of upfront investment, and keeping that machine running for the maintenance activity, that is also a costly operation. And in those specific scenarios, you can create a 3D experience, a simulated environment in a VR, and you can create a 3D model of the aircraft engine, and can even explain the entire operations of the aircraft engine in that 3D simulated mode. So that gives you a benefit of you can bring whatever contents we wanted into the 3D environment instead of bringing that physical model into the real world. And similarly, in the case, let's say we have some training requirement when we onboard a particular set of employees into a, say, machineries like a steam turbine. And same the case with we cannot have steam turbines at every location of the company to train the employees. So one option is to send the employees to a location where they have the steam turbines there, or we can have a virtual reality experience where the entire factory and steam turbine 3D model is being rendered in the simulated environment, and we guide the user to perform all these activities using the controllers and with the help of the other sensors. So that's how the VR experience will looks like. Now, so this is typically the way you have seen. The VR device will have two lenses within it, and once you wear it, it just merges together to create one single view. Just like we have the binoculars, we have two lenses with two views. Once you bring it close to your eye, it merges to create a single view. Now, next I'll show you one typical use case that we use. Say,
Welcome to the Scient Virtual Reality demo. This VR application will step a maintenance technician through the process of replacing the smoke detector in a commercial aircraft
okay, I think maybe after this we'll discuss. Yeah.
To begin, use the controller to select the training module. Look through the cabin to locate the lavatory. Once there, a set of tasks will guide you to replace the smoke detector located in the ceiling. Utilize the baby tray as a work surface during the repair process. Using a screwdriver, remove the screws. Using a screwdriver, remove the screws from the air extraction hood assembly. Set the screwdriver aside and reach up to loosen the hood assembly from the ceiling fixture. Separate the tube from the hood assembly. Disconnect the power by unplugging the electrical wiring from the smoke detector. Now you can remove the hood assembly and place it on the tray. Using the screwdriver, remove the screws, nuts, and washers to separate the faulty smoke detector from the hood. Locate the new smoke detector and install it onto the hood assembly with screws, washers, and nuts. Lift the repaired hood assembly and place it in the slot in the lavatory ceiling. Restore the power to the smoke detector by connecting the electrical wires. Reconnect the tube to the air extraction hood. Now, the air extraction hood assembly can be repositioned back into the lavatory ceiling. Reinstall the grill cover on the air extraction assembly using screws to complete the smoke detector repair procedure. Virtual reality training for onboard maintenance tasks, like the smoke detector repair, help ensure more efficient and quality repairs can be completed on the actual plane, minimizing the time the plane is in service and getting it back in the air. This improves the customer travel experience and saves the airline's costly downtime. Learn how VR training can improve your maintenance training. Smoke detector
Okay, so
in a commercial application through,
so if you have noticed,
through the process of replacing the smoke
let me
detector.
hold, yeah. So in this particular use case where we help the technician to remove the smoke detector, we simulated the environment inside an aircraft lavatory, and you might have noticed that in that simulated environment, the technician can in fact hold the handle of the door and open it, just like we do in our real world.
In a commercial aircraft lavatory. To
And
begin,
so
use the
here,
controller lavatory.
yeah.
Once there,
So here you can see the simulated
lavatory.
environment of an aircraft inside the aircraft.
Once there, a set of lavatory need you to replace located in the ceiling.
Yep. So in this particular step, you might have noticed that we changed the controllers into a glove so that the user who is using the VR application has a feel that he's interacting with his hand, though physically he's holding a controller in his hand. And whatever actions we typically do in real world, like holding, then closing the fist, pulling the objects, so all those kind of interactions are very much possible in VR, and that adds more kind of realism to it, so that the learning experience will be more improved for the user. Now, again, coming from the let's talk about some of the use cases that we could typically use in an education sector, where let's say there's a chemistry lab where the students has to deal with a lot of chemical component and the acids and other items. So we can have a simulated chemistry lab, and they can do the experiments at their own pace, so that they can do it, try it, and learn it by themselves and come up with the results of the actual experiment, rather than basing the entire materials that are required for in a lab environment. But the idea is not to replace the real learning we have in lab, but the purpose of VR is to give them a extra push so that they can go back and try it by learning at their own pace till they get the entire knack of that particular experiment or a subject. Now, we can also have one more additional factor. It doesn't mean that when you have VR training, we will make sure that the students will learn everything to 100%. So to help improve the learning capacity of the student, we can in fact capture different telemetries, like let's say there are 10 steps in completing an experiment, and we can capture the different time period that takes for the student to complete it from 1 to 10 step. Then we do an average against all the students who have done it. We get an idea of which step the students are getting stuck, so that the teachers could focus more on where they should train or give extra coaching to the students so they can scale up and pick up the entire subject. Those are some of the areas where we could use virtual reality. Now, it's not something, the VR is not limited to the training part where we show you how to do things and learn by yourself, but we can also create a concept called a digital twin. So what a digital twin means, let's say we have a factory and we want to create the exact replica of the factory along with its working condition. So that is also possible in the virtual reality. So I'll take you through one demo where the digital twin of a manufacturing plant is being done. So this is the actual factory. This is one of our facility in Mysuru. So where you can see different assembly lines and technicians wearing the safety mask and the coat and the regular safety items.
Welcome to the Scient Virtual Reality Demo. This VR application is designed to provide a virtual tour of Scient's smart printed circuit board manufacturing facility in Mysore, India. Let's begin the virtual tour.
So I just want to take one attention from your side. So if you have noticed in the inset, you can see a person who is wearing the headset and performing the activity. So that same will be simulated in this particular recorder. So what we have done is we captured this particular rendered 3D environment and this the person's activity as a separate video and merge it together. So you'll get an understanding of what that person does.
Using the controllers, users collect a smock, headgear, and shoe covers before entering the clean manufacturing environment. A digital avatar is provided to validate that the user is ready to enter.
Okay, so one more point I want to add here. In VR, since you wear the headset, you won't be able to move a lot in that, but in your real world, because you won't be able to see your surroundings. So in that case, in VR, we have a concept called teleporting, where we teleport the technician from one place to another with the help of a controller. So if you have noticed, you can see a red indicator going in. That's showing that you cannot move to that because that he's trying to move on top of a physical object in that space. So where you in the follow-up video, you can see a green arc, a parabolic one going on, helping him to move from one place
to
to
enter
another.
the factory, the application will prompt you to scan your security badge. For quality and safety purposes, the app will remind the user to verify if an electrostatic discharge strap or an ESD strap is worn correctly to avoid damaging sensitive electronics on the production line.
Yeah, so this is what I was referring to. So the person has pressed a particular button in the controller and lifting his arm. So you can see a line going in. That shows that the green line shows that you can teleport to that particular location rather than walking here.
As you enter the facility, you see an exact digital twin of the manufacturing lines and equipment at scale in the virtual app. You can teleport around the virtual environment and use the controllers to explore. Our 3D capture process provides a high-quality, detailed simulation of the design-led manufacturing environment to visualize the facility layout, specific equipment, and safety messaging. Virtual tours can be customized to train technicians, introduce teams to process changes, or provide executive reviews of production performance. This smart factory has integrated real-time IoT data into its operations to improve productivity and quality. The VR application helps the factory stay connected across company locations, the supply chain, and customers to improve communication and customer satisfaction. Sensors placed strategically in the factory capture streaming.
Okay, so in the interest of time, I'm just skipping this, but these videos are available in YouTube. Maybe I could share it post the event. So now we'll take a look at what the mixed reality technology is. So just to summarize, in AR, you bring the digital content into our world. In VR, we are being teleported to a simulated 3D environment. And there is one more technology area where both AR and both AR starts merging with our real world in a different aspect, where it starts understanding our environment. It's called mixed reality. So typically, I bet most of the people might have seen this movie and got fascinated with it, where the character is holding a digital object in his real world. So this is what something coming close using a mixed reality technology. So I'll play back a video.
Microsoft HoloLens brings holograms into your real world. Using transparent lenses, spatial sound, and an understanding of your environment, holograms look and sound like they're actually part of the world around you. That is mixed reality. With Microsoft HoloLens, holograms are viewed through the holographic frame centered in the middle of your view. This preserves your peripheral vision, so you can move freely and connect and collaborate with people around you. Holograms in mixed reality don't block out what you can see and hear. This enables you to engage with digital content and tools alongside the objects in your real world. Holograms can be world-locked in a physical location, so you can walk around them, or they can travel with you. You can even hear them in 3D with spatial sound. Microsoft HoloLens is the world's first fully untethered, self-contained holographic computer. With the mixed reality experience of HoloLens, you can stay in the real world and interact with real people as you simultaneously explore 3D in 3D.
Okay, so what you have seen right now is the mixed reality technology. So I'll move to the
Lens brings holograms into your real.
Okay, so this device is an untethered device, which means you can wear it just like your glasses, and it comes with a lens, so which means you can see your real world environment. So you can wear it and you can walk around. Both of your hands are free. And when we launch a particular app, with respect to it, you can place digital content in your real world itself. So you can walk around and experience it just like pretty much we see the digital content in our real world. And it's not about just
spatial sound and an understanding of your environment.
So if you have noticed this blue lines that are coming in, so what the device does is it scans your environment and does a proper segregation of what all are the flat surface, what all are the couch, table, wall, and ceiling. The device is intelligent enough to do that. And once that is done, you can place your digital content on top of that scanned environment. For example, let's say you scan a table and you can literally place a flower pot or any other content on top of that table, and it sticks firmly into it. So that kind of intelligence is...
Holograms look and sound like they're actually part of the lens. Holograms are viewed.
Now, there is one more concept I wanted to discuss. So this is common for both AR and VR. If you have noticed, 3 users are wearing the HoloLens and they are viewing the content. So there is a concept called the shared experience in both AR and VR. So what it does is it allows more than one person to be part of your experience, and so that you can take collective action. Similar to we have meetings and conferences where everybody comes into the same room and discuss to finalize a particular outcome. Similar to that, in AR and VR, you can have wear the devices and you can join in the same session so that everybody can see the same content and discuss on it. For example, let's say you want to do a design review of a particular car model or something different, or verify some functionality. So you can have more than one person to join in. It is not necessary that they should join in the same location. They can also connect from a different location. In that case, that person will be shown as an avatar in your environment. So that way you can even extend this particular technology. Now, so in mixed reality, we are merging the real and the virtual world to create a new environment where physical and digital objects coexist and interact in real time. So that's mostly with the spatial understanding, we call it as, where it understands your real world to perform an activity. Now, so what makes this technology unique is one, it is untethered. So it is you can wear it and you can walk around. There is no wires running from the device. and it's a Windows PC asset, so you can run I mean, it has the power of an average laptop, and that too is an untethered. Then it has spatial understanding, which means it understands your environment, so it separates out your wall, the ceilings, floor, everything it does. And inside out tracking means it scans and understands your real world and mark your position in that particular real world so that they can position a particular digital content. And it has eye and hand tracking, and the interactions are natural, means you can look at it, a particular object, you can touch a particular hologram, and you can even use your voice to perform a particular activity. So yeah, so this is the, okay, I think, let me see if I can hide it. Okay.
So sorry for interrupting you, sir.
Yeah.
Sir, can you show me actually real life applications in Unity using AR, where we are using
Okay,
the AR?
can we take the questions in the end? I
Okay,
just have
fine, it's
2 or
fine,
3 slides.
It's fine. It's fine, sir.
Okay. Yeah. Now coming to the spectrum of mixed reality. So this is how the augmented reality, virtual reality, and mixed reality looks like. So augmented reality, it augments your real world with helpful information, then blends holograms and transport your virtual world, which is only limited to virtual reality to a certain extent to mixed reality, and only virtual reality replaces your real world. Now I'll show you one more demo. So this one is captured using a HoloLens second version device for one of my recent conference. So what it does is I brought in a diesel engine running from cloud and doing all the manipulations like the cross section, explode, implode, and changing the colors and lighting. So I'll quickly play this one. So yeah, so if you have noticed, I just touched on a particular menu. So now this entire 3D model is exploded mode. So I can see the details inside this particular 3D model. So just want to add one more thing. This is a capture from the device because obviously quality is kind of less. But when you view through the device, it comes with a 2K video quality. Sorry, 2K rendering quality. So you could see that I launch the application from one angle and I'm walking to the other side, and the object is staying firmly to there because it understands my environment and where I place the object. Okay, so again, the interaction is just like touching one of the hologram menu. So you can interact with it like moving to different places. So, those kind of, I mean, typically whatever we can do in a real world is technically possible with this kind of technology. So, okay, so just, you might have noticed that I just use my fingers to pinch, hold it, and move it to the other side. So okay, so this one allows you to do a cross section where you can hold it and see the internals. So either you can interact by gestures like holding your fingers, or you can even hold that particular blue frame and you can move it by your own hands. So the beauty about the mixed reality is you don't need to use any controllers, just like in VR. So you can use your bare hands to interact with. So you can see that I'm just holding it and moving it to do the particular cross section there. Okay, so rest of the video talks about changing the colors and adjusting the lighting. So I'm just, let me see. Yeah, so here I change the color. Okay. So I just skipped, and so we can also set a lighting condition for the particular model, just like we apply a tint to the camera while taking a photo. So the environment light adjustment is also possible. Okay, so then, yeah. Yeah, so we'll quickly run through some of the use cases, but keep in mind that this use cases can be executed both in AR and VR with respect to the, with respect to what all problems you want to solve. One scenario would be where we have an engineering and communication where you want to build a plan and want to visualize it. So this is totally possible with the AR/VR technology. You can have the digital model in your real world or in a simulated environment and take a walkthrough on that. Then in architecture and construction, so even before we start building it, you can use you can use preview the 3D model in your real world and see how does it looks in a real life. Then in healthcare, let's say you have some data coming in your tablet that has that contains medical data. So that can be translated into the 3D model representation with the readings from your MRI scan or some other metrics from the medical devices. And for product design and presentation also, you can use this. Okay, so I think we just come close to the end. Now coming to the augmented reality part, you can either use your Android and iOS devices for virtual reality. You can have Oculus or HTC Vive devices, and for mixed reality, it supports Microsoft HoloLens and Magic Leap device. So that's the wrap. Okay, so thank you so much for your time. Yeah, I could take questions now.
Thank you, sir. Thank you for that wonderful presentation. I already have a few questions. So,
Yeah, sure.
Mohammed Shamsul, sir, he's asked you the question that can we have any kind of demo on AR?
Demo on AR? I didn't get that.
Yeah, just a moment. Shamsul, sir, you can unmute and speak to the speaker. Sir, we can't hear you, sir. Shamsul, sir. Okay. Yeah. Yes, sir. So again, it's on. No, sir, we still can't hear you, sir. Okay, by the time Shamsul sir is getting his audio fixed,
Okay.
Suman sir, you wanted to ask another question, sir. Suman sir, you can go ahead.
Good afternoon, sir.
Yeah, good afternoon.
Sir, I have one query, which is like real life applications where we are using the AR. Whatever you have shown, that is all are real life applications. Can you show me one kind of real life applications in Unity where we are using the AR?
So all the applications that I have demoed here is developed by so my team only. The entire application is developed using Unity. So you are asking to open a Unity and how to create an AR application?
Yeah.
Okay.
Yes, sir,
so
yes.
So that exercise will take a minimum of 15 to 20 minutes. So that, I think the time slot is just for 1 hour.
Yes, I'm sorry, we don't have that time.
Okay.
But sir, I think whatever things that would be much better if we having a practical experience, because such videos already we are seeing from last 1.5 years and all. So
I'm sorry.
Actually, such videos we having also as a teacher we having experience about these things. So So if you are going with a practical hands-on experience, then only I think that would be much better.
Okay. So when you say practical hands-on, is it something like a workshop, or how does?
Right now, like 15-minute quick demonstration, like we can go and make one small product and just quickly interact with that product using applications. I think the same Suman sir is asking, if I'm not wrong.
Yes, sir.
Okay,
Yes, sir.
so that will take a minimum of 30 minutes because we need to configure few things before we get started with the demo. But for some reason, I don't had that agenda when we first discussed this. Else, I would have prepared for a one live demo during the session. Yeah,
Sure,
or
I
possibly
think,
we can plan it at a later time. I guess.
Yes, we will plan it. Ajay sir, if you are there, if you could take a note on this, then probably we can get in touch with Abilash sir, and we can include what we have missed out on today.
Yeah, we can do it. We can do it. Yeah, no problem.
Thank you, sir. Thank you. Yes, anyone else? Prabhakar sir, you had one question. Prabhakar sir, if you're there, quickly. Shamsul sir, is your audio working? Hello, mic testing. 1, 2,
Okay.
3.
Ma'am.
No, we can't. Yes.
Yeah. Yes, ma'am. 1 minute, ma'am. Yeah,
Yes,
I need some practical things.
Ah.
Okay, so that's why I asked you.
So I think Prabhakar sir, that question has been answered. We will connect with him because he will require some more time to do that. And as it is, we are running short of time, and we've just given him 1 hour. So we will connect with him later, and we can fix, do that for another session. Yes, Bhavna ma'am.
Yeah, sir, thank you, sir. It's a wonderful session. Sir, I had a doubt here. Maybe it's a query. What is the advantages of this augmented reality and mixed reality, sir? How it differs? I'm feeling like almost similar.
Okay, so I would say mixed reality is an extension of an augmented reality. The real difference comes in, let's say, in AR, when you use a mobile and tablet, we are in fact using one of our hand. We are dedicating one of our hand for holding a device, which means we are being stopped from using the full advantage of the technology. Let's say we take say a repair kind of activity in augmented reality on how to unscrew something and assemble it back. If you are going with a mobile and tablet, then you have to hold the tablet in your hand, then scan it, see it, keep it down, and do it. So from a user experience factor, that is not something the end user is ultimately want to see. Now, coming to mixed reality device, if you have noticed in the very last demo I have shown, so that is a demo that I captured with HoloLens 2, where I wear the device and both of my hands are free, and I can touch and interact with the holograms, or I can touch and interact with the 3D model, and pretty much we do in our real world. So where mixed reality are kind of a more compute power device, where you can wear like your glasses, and you can just walk around and do the activities. So, and it's not limited to that. It also has your environment understanding, so that you can place an object directly on the table, and the interactivity part, you can touch with your hand, you can talk to it. For example, in HoloLens, there is a voice assistant called Cortana coming in with the device. So let's say you want to take a photo, or you want to start a recording of a particular demo or an application that you're running. You can say, hey, Cortana, just start recording. That will start the recording. So it has the more intelligent kind of stuff baked into the device out of the box. At the same time, if you talk about the AR experience in mobile and tablet, there is no default experience baked in. So everything has to be done by yourself. So mostly AR and MR is in fact an overlapping, extension of an AR, but the extra intelligence makes the mixed reality more differentiated from the AR part.
Yeah, yes, sir.
Thank
Actually,
you, sir. Thank you, sir.
Yeah.
3 months back, I saw one article in paper in Kerala schools and all. They have started using this VR and AR technology. So there, for kindergarten students, if the teacher wanted to show, talk about elephants and all, so
the elephant will appear in front of them, and a teacher is started teaching. I mean,
Yeah, correct.
so,
Yeah.
yeah,
Even I
yeah.
think that was circulated in social media. I have seen that, I
Yes,
guess.
yes.
Yeah.
Exactly.
Okay.
So
Okay.
it's a great technology, because for all the teachers like us, definitely we should learn much about this. I mean, about this technology. And as others said, like we need one more session to show like a simple example. So
Yeah,
To
even
sure. We'll do
see
that.
exactly
Yeah.
how this works in, like, in the space, like how exactly you bring in a 3D element and how you link it with each other and all that. I think that
Okay.
would be much
Yeah.
more easier and better for us to understand how this technology works.
Okay. I think we can plan for that, because I remember the request came in 4 days back.
Yes, yes.
Then there is a lot of discussion going on, figuring out and finalizing what content to be shown. So that's where this demo part missed out. So usually, since it said it was mentioned the session is for faculty, so I thought maybe I shouldn't talk about anything on the developer side. So that's the reason I intentionally removed this particular one. So usually for all the talks I cover, I address developers. So usually it ends with a developer demo. But since
Yeah.
this was faculty, I didn't expect that. But no problem, we can have it organized on another day.
Actually, all our faculties come from various different domains. So not
Okay.
all are exposed to the same. So some are only from animation, some are from digital filmmaking, some are from only the gaming part. So probably
Okay.
those who are gamers or gaming people, they have an idea about Unity. But when we talk about digital filmmaking people who are cinematographers and photographers, probably they are not very much, they know the technology, they know about AR, VR and MR, but they probably don't know how it exactly works. So probably that way a demo, a demonstration of the actual working would be really helpful. So I think
Okay, got
we've
it.
already
Yeah.
addressed that issue, and as Ajay sir has already said, that we will connect with you once again, and
Okay,
we'll
sure.
have one session for another hour where we can, see the actual demonstration on this.
Yeah, sure, no problem.
So
Yeah.
thank you very much, sir. It was really nice, and at least I got some good insights. Although I knew a little bit about it, but I think with all the demos, all the videos that you had given, it was very well illustrated, and it's absolutely clear. It's like picture clear in our minds. So thank
Okay.
you very much
Thanks
for
a
this
lot for
wonderful
that.
session, sir. I would just request you, if in case you could just drop on in the chat box, if you could just drop the links, whereon we could see those the YouTube links which you said for the videos which you use. If you could just drop those links, so then we could share it with our faculties if anybody would be interested to.
Yeah, sure. Maybe I'll revert back to the same email thread which we are having.
Sure. No problem,
Yeah.
sir. Anytime.
Okay.
Okay. Thank you so much, sir.
Okay. Thank you, everyone.
Thank
yeah.
you.
Bye-bye. Have a good day.
So thank you, everyone. I hope you enjoyed the session.